Hello everyone, welcome to the sixth lecture from the chapter Light, Reflection and Refraction. In this video, we are going to learn about image formation using concave and convex lenses. How the formation of image takes place in a concave lens and how the formation of image takes place in convex lens. So let us first understand what is a concave lens. So as you can see on your screen, so a concave lens is a lens which is thin in the middle and thicker at the edges. Also, this is a diverging lens since you can see that the ray of light that comes parallel to the principal axis is being diverged out. It's going outwards, it's spreading out. So that is why we call it as a diverging lens. This kind of lens always forms a virtual image which will be diminished in size for real objects. And we will understand this better once we start with the ray diagrams. Then a convex lens is exactly the opposite of a concave lens. It is thicker in the middle and thinner at the edges. So it's also known as a converging lens because as you can see here, it is converging all the light rays at one point. So all the rays of light that are coming in, they are getting focused at one point on the right hand side of the lens. So that is why we also call it as a converging lens. So this kind of a lens can form a real image or a virtual image of the object depending upon where the object has been placed in front of it. We'll understand this better once we understand the rules for the image formation, and then we'll be drawing the ray diagrams just like we made for mirrors. So these are the rules which we'll be using for drawing ray diagrams for lenses. Rule number 1 says when a ray of light is parallel to the principal axis, then the refracted ray will pass through the focus. So this is applicable both for convex as well as concave lenses. So when we label the ray diagrams or when we draw the basic structure for the lenses, it is to be just kept in mind that you can draw this either using a compass or you can also draw it freehand. So what I prefer to do is I take a central line, a vertical line that I've made. This is the central line of reference, and I draw a line perpendicular to this like this. So the horizontal line that I'm making, this is the principal axis. The center of the lens is known as the optical center, so I mark it as O. Now, since lens is a transparent piece of glass, it has focus on both the sides. So what we can do is we can mark this as focus 1 and we can mark this as focus 2. Then in case of mirrors, we used to mark the center of curvature. In case of lenses, instead of center of curvature, we mark the distance as 2f1 and on the right hand side also as 2f2. What is to be kept in mind that the distance between optical center and focus 1 and 2 focus 1, optical center and focus 2 and 2f2, these need to be exactly the same. So what I suggest is you do this using a dimension of 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters and 2 centimeters, and when you do this, I am very much sure that your diagram will come out to be perfect. So these are the basic labels that you need to put in while drawing the ray diagrams for lenses, whether it's the rules or whether it's the actual set of ray diagrams. So let's get back to the rule. So rule number 1 is a parallel ray of light which is parallel to the principal axis after refraction passes through the focus. So in case of a convex lens, which is a converging lens, it goes inwards like this. Whereas in case of a concave lens, which is a diverging lens, it goes outwards in such a way that if you extend it in the reverse direction, it will appear to pass through the focus. No doubt it doesn't go through the focus, but it appears to come in through the focus. That is what it looks like. This is rule number 1. Rule number 2 is very, very simple. A ray of light that goes through the optical center goes straight, no bending, no deviation for both the lenses. Whether it's a convex lens or it's a concave lens, it simply goes straight and does not bend at all. The third rule is the exact reverse of rule number 1. A ray of light that comes in through the focus becomes parallel to the principal axis for a convex lens, and for a concave lens, a ray of light that comes in line with the focus. So obviously it is not passing through the focus, but it's coming in line with the focus. So once it reaches the lens, it becomes parallel to the principal axis. So that is why I said we mark a line of reference in the center of the lens so that you can show the bending only from one point. So that makes it simple. Now let us discuss the image formation in case of convex lenses first. In case of convex lenses, we will be having 6 ray diagrams for different positions. The first one that we have taken up here is when the object is placed between the optical center C and the focus F1. So this is our object. Optical center is O here, not C, sorry. And we can correct this as O. So the object has been placed between the optical center and the focus. So let's have a look at how it's made. I can just draw a rough figure for you for your ready reference how to go about it if it comes in the exam. Just draw your lens like this. Draw the principal axis. Mark the points that we discussed O, F, 2F. So this is focus 1 and 2F1. Then F2 this side and 2F2 on the other side. Remember, the distances that you have taken need to be absolutely the same. Place your object between the optical center and the focus. Use the first rule, a ray parallel to the principal axis. After refraction, passes through the focus. This is rule number 1. So if you feel that you need to draw along with me, you can just pause the video at this point and draw the diagram. And the second rule we'll be using is through the optical center. So it goes straight like this. And we find that the rays are diverging on the right hand side. So this is the actual path where the light traveled. Now we are going to extend these rays in the reverse direction using dotted lines because this is somewhere the light hasn't gone yet, but we are somehow manipulating it. So this is where it goes. Wherever these rays intersect, it's going to be your image. So my diagram is a bit what I can say, the rays are crooked since I have been drawing freehand, but for your reference you already have the one that is perfect on your screen. So what about the 3 parameters of the image? What kind of image is formed? Where is the image formed? And what is the nature of the image here? So as we see here, the image is formed behind the object. So this is our object and the image can be formed anywhere here. It's not that it's going to be formed beyond 2F1. It could be anywhere behind the object. So it is behind the object. It's virtual and direct because the light actually didn't go there. And it is obviously larger than the object. It's much bigger than the object. So we can also use the word magnified here, that the image formed here is magnified. Let us now have a look at the second ray diagram when the object is placed at the focus of the convex lens. So now this is our object. The same set of 2 rules to be used. A parallel ray passes through the focus and the one through the optical center goes straight. And you will be getting a parallel set of lines which indicates that the image will be formed somewhere very, very far off. So we can say that the image will be formed at infinity in this case because these rays will travel somewhere very far off. That is what these dotted lines indicate here, that the rays are going till an infinite distance and they will intersect somewhere very, very far off. So what are the various parameters associated with this one? Image is going to be formed at infinity. Obviously, it's the real light rays that are traveling. So it's going to be a real image and real is always inverted. So real and inverted. And the farther it goes, the bigger it gets. So it's going to be highly, highly enlarged. Now let us discuss the third case in which the object has been placed between the focus and 2F. So you can see the object is placed somewhere in between F1 and 2F1. And this is our object here. So again the same set of 2 rules to be used. All these diagrams are exactly the same. A parallel ray after refraction passes through the focus here and the second ray passes through the optical center. So these 2 rays, they intersect at this point and we get the image here. So what do you think are the 3 parameters of the image being formed? The image is formed beyond 2F2. So it's formed after 2F2. It's real and inverted and it's magnified. It's bigger than the object. In the fourth case, the object is placed at a distance equal to twice the focal length. That means the object is now placed at 2F1. So this diagram is the one which needs maximum caution to be made because if you are making your lens with a compass, then it's going to come out perfect in the first go. But if you are using a freehand lens, if you have made your lens freehand without dimensions, then there may be a problem which you have to be very careful about. The rules are the same. A parallel ray passes through the focus and the second ray passes through the optical center. So the point where these two rays intersect, this is going to be your image, but your image should be at 2f2 on the other side. So if your object is at 2f1 here, your image has to be at 2f2, neither slightly left, neither slightly right. So this is the one that needs maximum practice, and I think you'll be able to do it well. So the image formed will be at 2f2 or 2f dash. It's a real and inverted image. As you can see, it's upside down, and also the size of the image should be exactly the same as that of the object. So be very careful while drawing this one. Draw it 2-3 times and get an expertise on this one before you proceed to the next case, that is case number 5. So now we are moving the object even more away from the lens. Now it's being placed beyond 2f1. So this is our object here, AB. A parallel ray passes through the focus, through the optical center, goes straight. So the same set of two rules being used again. So the rays are intersecting at this point, and this is where we get our image. So wherever the rays intersect, we get our image. So a minimum of 2 rays are required for drawing any ray diagram. So this is how we get this particular one. And if we look at the 3 characteristics of the image, it's going to be formed between f2 and 2f2, or between f and 2f, or between f dash and 2f dash, whatever way you label it. It's a real and inverted image, upside down, and this time the image is going to be smaller than the object. So this was case number 5. In the 6th case, when the object is placed at infinity, so the rays are coming in parallel. So a parallel set of rays indicates that they are coming from somewhere very, very far off. And since it's a converging lens, all these rays, they will meet at the focus. So only the first rule is being used here. A parallel ray after refraction through the convex lens goes to the focus on the other side. So this is rule number 1, which is used here. And the characteristics of the image formed in this one would be, the image is formed at the focus on the other side. It is going to be a real and inverted image because we see the light rays are actually traveling to this point, and it's going to be a highly diminished image or a point size diminished because it is very, very small in size. So these are the 6 ray diagrams which we draw for convex lenses, and after making these 6 ray diagrams, you must have observed that for a convex lens you can get a real image, you can get a virtual image, you can get a magnified image, you can get a diminished image. So all different kinds of images are formed by convex lenses. Let us now see how image formation takes place in a concave lens. So this one I am going to draw for you so that you can understand it in a perfect way, because this one is slightly complicated, and I would suggest that you draw along with me so that you can actually understand exactly how to go about it. So this is my lens, and I draw a central line of reference to show the bending of light. This is the principal axis, the optical center, f1, 2f1, f2 and 2f2, like this, right? Now I place my object anywhere in front of the lens. It could be anywhere. So I place it here. I use the first rule, a parallel ray. Now in this case, it doesn't pass through the focus, but it appears to come through the focus. So I begin with dotted lines, and this line then goes straight like this. Again, my lines are crooked because I'm drawing freehand. You please refer to the diagram already given on the slide. And then the second rule, through the optical center, it goes straight like this. So the point where these two rays intersect, this point, this is our image. Since one of the rays is real and the other one is virtual, we will get a virtual image. So the 3 characteristics of the image formed here would be, the image is formed between the object and the lens. This is our object and this is our lens. So the image is formed anywhere between these two. It could be anywhere. It's not like it has to be beyond f1 or before f1. No, it could be anywhere between the object and the lens. It is a virtual and erect image, and also it is diminished. So for concave lenses, we always get a virtual and erect image which is always diminished. The last ray diagram for a concave lens, a parallel set of rays. You can take 3 rays, you can take 5 rays, it's all your choice. It diverges out the light rays, and when we extend the diverged rays on the reverse, it meets at the focus. So this is the point where the image will be formed, and the 3 parameters here would be: the image is formed at the focus on the other side. It is a virtual and erect image because you see that dotted lines are coming in. It's not like the light is not actually traveling to this point, and since it's just a simple point, so the image is going to be very, very small. It's a highly diminished image, or a highly you can say a point sized image. That is how we define it. So these were the 8 set of ray diagrams which you need to know for concave as well as convex lenses, and also the rules which are very, very important. In the next video, we'll discuss the sign conventions, and also we'll solve some numericals based on the lens formula, power of the formula, and magnification.